poppin'? What's up, everybody? It's Jared, Midday Engineering here. Today, we're going to be doing another awesome video on Fanuc Robotics. Specifically, we're going to be going over PalletTool Pro, the PC version, and we're going to show you what it looks like on the PC, what it looks like on the Teach Pendant as well. But specifically on PalletTool, I tried to put all this in one video. I'm realizing the more I'm doing this is it's just too much to put in one video. So today I'm going to segment it into Infeed setup, pallet setup, and we'll go from there. So be sure to check out the chapters below. I categorize everything. So if you're just whizzing by and you're looking for something real quick, be sure to check out the chapters below. Also, I'm going to be attaching the Fanuc manual in the description below. I know sometimes that can be hard to get your hands on. As always, if you enjoy the content, you want to see more, or you just like my face, be sure to hit the subscribe button and smash the like button so that I know you guys are digging the content. And if so, I'll put more stuff like this out there. Without further ado, let's get into it. Oh, explosion. All right, what's up, guys? So let's go ahead and jump right into it. I am going to start with the infeed. This is where the robot is going to be coming in at. Really quickly, let's look at the manual so we can kind of see how, if you're looking at the manual, PalletTool Turbo. I don't really worry about PalletTool Turbo. Setting up PalletTool is where you're really going to be looking here. Fixture and fixture plate and pointer. We'll talk about this stuff. Sorry, I'm just checking up a few things here. So an infeed is what the cases are going to be coming down and feeding to the robot. So this long section here that I'm looking at with my mouse, this would be defined as the length of the conveyor. So when you first set up an infeed and a pallet, okay, you're going to want to make sure this is in the zone of the robot. You can really quickly check and make sure that the robot is able to reach these things using this bubble in the software. So let's look at setting up an infeed. Right now I have two infeeds there in the working area of the robot. So you see this area, this arrow pointing. That is pointing in the direction of the orientation of the cases feeding to the robot. So immediately when you're setting up a an infeed or a pallet station, you're going to see this language of width on length, length on length. So let's pull it up in the Teach Pendant and try to follow along. So we're doing an Infeed Station. I'm on Infeed Station 1. Let's modify. So we'll come back to that. So arrow direction, width on length, length on length. This is the orientation that the cases are coming down the conveyor in. Is the width, as the narrow side, the width side of the case leading, going down the length of the conveyor, or is the length of the case coming down the length of the conveyor? It's important to know this because that's where your origin is going to be. Your origin's either going to be over here on this side, or your origin is going to be over here on this side. So what I would recommend doing is, here's a real world example of these origins. So if your origin is on this side, which would be corresponding to this setup, which is width on length. I just know that that's that setup. But if your arrow's on that side, and this is about what your infeed is going to look like, you're going to want to have, this is going to be your origin. This is your corner, okay? This is where you have to have cases at in that corner. That is going to be your non-adjustable side. That rail does not move no matter what. That is always going to be your zero. The rail on the other side, on this side, is the rail that can move. This side is the static rail. This is what doesn't move. This is the dynamic rail. And this is your origin. So let's look at that on the Teach Pendant. So this arrow is supposed to be representing the fixture plate and the pointer. So the fixture plate is what that arrow is, And the pointer, these are things that are provided to you when you purchase your PalletTool robot, and you opt for this option here for a fixture plate and pointer. This is how Fanuc leads you through the manual. This is how they want you to set it up. So this is how we're going to set it up. I'm going to show you the standard way PalletTool wants you to set up, and then if we get time in these videos, I'll show you the customized version that we do. But this is what they expect you to do. They expect you to take this fixture plate, put it on the conveyor in the direction that you want your cases to be. So if it's going across the width of the conveyor, it is here. It's width on length. That's the orientation. If it's length on length, then it's pointing up the conveyor like this. So let's get our handy dandy pointer out here and let's attach it to our robot. And I don't think I have to remind you guys how to teach a pointer. If so, just look up, that's just basic handling tool to be able to teach pointer. So apply. This is PalletTool, so I can't. We're just going to leave my U tool right there. That's fine. There we go. There's our pointer. And you can see that my U tool is at the tip of this point. It's where you want it, right? When you teach your pointer. So when we looked at this earlier, when we click modify, it says set the robot to tool coordinates. Okay, are we in tool? Yes, we can double check by shift coordinate. Clicking tool. Okay, now we know that we are in the tool coordinate system. Align the gripper so that X positive direction jogs toward P2. As long as X positive is facing toward P2 and you, the pointer, is at P1, record. Record your pointer. Sorry, let me adjust this. Record your pointer at P1. And that's going to be your origin. That's how PalletTool, it's kind of like a user frame in PalletTool, except it's width on length, length on length. That's the terminology they use instead of user frames. So let's jog. Let's see if I can take the robot move to. And if we look at our tool, X positive is facing the direction of that point. X positive is going the direction of that pointer. You can also do a move to. You could do a move to on the Teach Pendant. It's kind of the same concept. So that's a little bit about teaching your Infeed Station. I personally, when I'm trying to touch up my Infeed Station, I personally do not use. I don't reteach the point. In fact, I go to the coordinates, and I'm going to show you how to do this. So it says Infeed origin top, but what is that? What is the XYZ up picture? What is the Cartesian coordinates of that top Infeed? Well, I'll show you how to adjust that X, Y, and Z. Okay, this is a little trick to PalletTool, and this is what we do. My boss says it's late because we're lazy, but really I think it's because he's a clever guy. So press enter. Okay, I clicked on PM Infeed 001. That is this Infeed. Infeed 01, Infeed 02 would be the other one. Same thing with your Pallet Station. Same thing with your Pallet Station. Your Pallet Station is PM STA 001 for Station 1. If it was 2, it would be PM STA 002. So I click on Infeed. Okay, how do you view this? Is a Karel program. How do you view Karel variables and positions? Well, you go to Data, Karel positions. You're going to be brought to this screen. So Data, Karel positions, Origin, Details. There is your X, Y, and Z. You can touch up. So say your robot, you feel like it's 50 millimeters in X, Y, or Z. and subtract the difference or add the difference. Or in rotate if your rotation isn't perfect, because I guarantee you it's not going to be a perfect 90 degrees like it is here in Roboguide, because it's a perfect world here, but I guarantee you it's not going to be a perfect 90 degrees in the real world. So that's a little bit about how we do our stations, and it's a little bit about how they expect you to teach your Infeed station. Pallet station, same thing. You take your fixture plate, you take your pointer, and you do the same thing. Now, in the virtual cell, I can move this around. I can move this pallet around depending on my rotational. Right? Okay, now the pointer is on the other side of the pallet. Okay, that's no big deal. The way PalletTool instructs us to build a pallet is you want it to point. I remember them saying this to me in the class. You want it to point in the direction that you're building the pallet. But that may not always be the case. And if it's not, that's totally fine, because guess what? You can compensate it for it in your pallet patterns, in your unit loads. And that's going to be in the next video. We're going to go over unit load, all that stuff. So let me just put this back over here. So let's move to the pallet station. Okay. Now X positive better be facing the direction of that pointer. And look at that, it is. X positive is, in fact, what's going on with my mouse? Sorry. Oh my goodness. I think I went a little too far forward. There we go. Okay, let's try that again. So we're on the pallet. Let's move to our origin, and then X positive better be facing the direction of our point. Remember, you're teaching. Okay, let's pull up our fixture plate again. You are teaching P1. So again, this is kind of like a user frame, but it's a little goofy because it's a little different, because you're using the fixture plate. PalletTool, Fanuc, they are expecting you to be using this fixture plate. Notice how P1 is not in the corner of the fixture, but it's inside this. So if you're expecting your origin to be down here into this corner, this is actual P1 taking into account the automatic position offset. So when you teach this point P1, just know that there's this difference between the corner and P1. So in the real world, when you're doing this and you're thinking, well, this origin doesn't make sense, just remember this distance between P1 and the corner of the faceplate. Here they're saying that the actual P1 is taking into account the automatic position offset. Okay, take that for what it's worth. So here's how they recommend you setting up your pallet stations. So this would be what a width on length pallet looks like, and apparently this is what a length on length pallet looks like. That looks like a square to me, and not a 40 by 48 pallet. But this is just an example, kind of showing you different setups, different things that you can do. Infeed setup. Okay, where are we at with time? Oh man, that is it's really rough to look at. Yikes. Okay. So that is our pallet station and Infeed station setup. Let's go ahead, since we have time here, let's go ahead and do a slip sheet dispenser. So fixtures, add fixture, slip sheet dispenser. Now in Roboguide and PalletTool Pro is the PC version, there has to be a physical slip sheet dispenser like I just did somewhere in the program in order for this to work. Okay. Let's get our work envelope back out of here. Make sure this giant M410, probably way more than I need for this application, but It'll get things done. Make sure that I can reach it. It's fine. Again, it's a virtual robot. It doesn't need to be perfect. Lock all locations. Apply. Okay. So you saw how I added that in. In the real world robot, you don't have to add a slip sheet dispenser. It does not care. It doesn't care that you add a slip sheet dispenser. There are a couple things that you have to do. One, you have to teach the correct position registers. Let me see if I can pull that up for you so that you can get a screenshot. Okay, guys, I'm going to put this in the. I'm going to try to put this in the description. Okay, here's our position registers. Here's the ones that you need to be teaching, okay? There's a slip sheet place pos. I know sometimes it's different for PalletTool Turbo and PalletTool Standard, whatever. And it's different if you're depalletizing, right? We're palletizing, so slip sheet position register assignment, PalletTool slip sheet position register assignment. So just jot these down because these are the PRs that you're going to have to record your search. Remember, it is a skip condition that you're using. It is going to start from your slip sheet search position. And if you don't know what a skip condition, look it up. You can find it on the internet. It starts from your search position, and it's going to search down to the bottom of the slip search end, and it's going to be looking for the digital input or how the skip condition become true. Once it's true, it's going to skip label. If it continues and it reaches the slip search in position, then the slip search failed, and you can do some other sequential things because it failed. You come back up. There's a lot of different things you can do. What we do is we do a try again or false alarm or a slip sheet drop, which I believe that's also what PalletTool does, but we do it in a way for the HMI interface. So let's look at the Teach Pendant real quick. Let's see what that looks like on the Teach Pendant. Those PRs. Data. I'm already on data. I know it's somewhere around here. Slip found. Slip found. Slip search. Slip search start. Slip search end. Another thing with the pallet search start. Sorry, that's not the right one. Slip search end. Slip search start. Another thing with PalletTool is with Turbo, it's going to try to find the quickest path back to that slip sheet. So when it's searching for that slip sheet and it found it, the next time it comes back around, it's going to go back to that found position, and then it's going to be able to start its search. It's going to retain the Z height of where it found, and then it's going to start searching again. Here's why I don't like that. Because what if every time somebody opens a gate, every time safety is broke, or if anytime somebody entered the cell, how do we know that they didn't just add slip sheets? So that is opening the margins for a collision. So I usually take the slip sheet search found position out of my program, and I make it search from the top every time. Now, if I'm hurting for cycle time, I'll allow it to come back to that slip sheet search found position, but I'm going to add probably 200 millimeters in Z. Pick, slip, stack. This is going to be your program it's going to be looking for. We can come back to that here in a little bit. I want to show you what else you need to do. So you need to teach the position registers. Hopefully PalletTool for the virtual robot, I think it does it for you. But in the real world robot, you're going to have to teach those PRs. Not only do you have to teach the top of it and the bottom of it where it's empty, but you also need to teach the slip search placement positions. Now they have 1, 2, 3, 4 for 4 different pallets. So if you have 4 pallets, you can have 4 placement positions. 1 slip placement for each pallet. So if I had 2 pallets, I would teach slip placement 1, slip placement 2. All you're doing is teaching the bottom of the pallet. PalletTool will do the rest. PalletTool will do the rest. It'll calculate the Z height as the unit loads go up based on product dimensions. It'll do all that's the magic with PalletTool. It'll do the rest of it for you. It'll calculate path. and the Z height, all that good jazz. So since I only have one pallet, looks like it's already recorded, I only need slip placement 1. If you had a pallet dispenser, same thing, same exact thing. Now, to initiate, now this is getting a little bit ahead of myself, but I have to show you this for the slip sheet dispenser. To initiate a slip sheet, there has to be a positive value on the layers when you're doing your unit load setups. So let's look at the Teach Pendant because it's really easy to do it on the Teach Pendant. So if you go menu, setup, unit load, modify, this is our YouTube unit load, layers high, whatever. I just click details and then layer spacing, details. Okay, this is the spacing of the slip sheets. So if I put a 5mm value in here, it's going to initiate the pick, slip, stack routine. So if I put 1 in here, it's going to go pick a slip sheet, and it's going to add 1mm to the Z height from that layer and up. Trick is, if you wanted to kind of cushion, if you wanted to actually press down on cases as you're placing them, you could actually come in here and put a negative value. Put -20. That's probably way too much. Put -5. That's actually going to cushion the cases a little bit. It's not going to call a pick, slip, stack. So if you're positive value, but if you have a negative value, that's a way to cushion your placement positions as you're placing cases for that layer without having to increase the Z height of your dimensions or increasing or decreasing the Z height of your pallet station, which will affect every single unit load. This is just a way to manipulate for a single unit load or a single layer. You notice, hey, you know what? Layer 4 is starting to place really high. First thing I'll look at is your case dimensions. The second thing you could do is come over here and say minus 10mm. And it's going to subtract 10mm from there and up, from layer 4 and layer 5 and above layer 5. If you placed another one, it's going to be minus everything from there. It's going to be minus 10mm. So that's what you have to do to be able to initiate the pallet dispenser. Excuse me. On the unit load setup, I'll very quickly show you, but we're going to do this in the next video. When you click over here in your palletizing parameters, you right click, slip sheet above. You want to put one below, slip sheet below. Here's that height. Okay, we better get off the screen. It might blow up. Here's that slip sheet height. Usually 5mm is a pretty good number. 3mm. That is what's going to go and initiate the pick, slip, stack routine. That is going to say, look, is the pick, slip, stack required? And it's going to equal 1 for yes, and it's going to call that routine. So just remember to teach your PRs. Make sure you got the positive value in your layer spacing or your unit load setup. What I showed you on the Teach Pendant and on the unit load setup here on Pro is the same thing. It's just a different way of getting to it. Also, guys, we want to set up the IO for your Infeed and Pallet stations. Pallet present, cases present, and we can look at IO really quickly for your slip stack. So let's look at the pick, slip, stack routine for picking a slip sheet out of the slip sheet dispenser. So there is going to be some comments in here. PalletTool does kind of a good job of telling you what's going on. Modify, skip condition. Here's going to be place 1. This is where we're going to be looking for modification here. Is it actually robot input 1? Or is it a digital input 57? This is where you're going to be looking for that digital input, a vac switch, a photo eye. What we usually do is we do a fast search and a slow search. We do a fast search until the photo eye detects at 300mm detection range. Digital input 1 comes on. Then we do a slow search, going much slower until the vac switch turns on, at which point we draw vacuum. And that turning on vacuum is where you're going to have to add this IO. Slip sheet found. This is where you're going to turn off your vacuum because guess what? It wasn't found. If you have a slip sheet dispenser, you have to have a vac switch. At the very least, you have to have a vac switch. If that's all you have is a vac switch, you're going to be doing a very slow search each time. because it has to be able to draw vacuum, turn on the digital input, then tell the robot to stop, all within milliseconds, so that doesn't the robot doesn't crush. And thankfully, it's just cardboard most of the time. It's just cardboard, and it can have a little bit of a cushion there, but that's why you have to do a slow search when you're using only a vac switch. That's why we do a photo eye and a vac switch, so it makes it a little bit more optimized. Slip sheet found position. They tell you right here, add IO here to turn slip sheet cups on, turn vacuum on. However you're grabbing that slip sheet, this is where you're going to be turning that on. That's it. As far as your slip sheet IO, this is where you're going to be turning it on and off at. Down here, let's go look at when we place it. So we're at the slip placement position, 452, jump label 70. Here we go. Okay, this is at the placement position. Add IO here to turn slip sheet cups off, because now you're at the placement position. Line 35. This is where you're going to be adding your IO to turn the vacuum cups off when you're placing it. So you need to be able to turn them. You need to find the place where you turn them on or off, depending on whether you found the slip sheet or whether you didn't. And you need to be able to turn it off after you place it. Boom, slip sheet done. Infeed IO. There's two ways you can do it. You can do it in Pallet Pro. I don't mess with it in Pallet Pro. I just leave it the way it is because it's only for simulation purposes. Railroad Robot, gotta have IO set up. So Infeed Station. Next, gotta hit next to be able to see this. I know some of the simulated fixtures are kind of hard to get to. Set IO. Infeed unit present signals. So I have three cases. DI1, DI2, and DI3 for unit 1, case 2, and case 3. Those are going to tell me I'm ready to come and pick. If there's only two cases, I'm going to sit there and wait for DI3 to come on. Done. Unit request signals, telling the PLC whatever you're telling, saying if I'm requesting for unit 1, 2, or 3, is I'm going to have digital output 1, 2, or 3 on. Infeed unit orientation signals, I do not use these, so I'd have to refer you to the manual if you are going to be using the orientation signals. Let's look at Pallet Station. Again, press next, little hidden IO button here. Pallet present signals. This is important. This is extremely important because this is how Roboguide, this is how PalletTool is clearing your pallet data. So once it has finished your pallet, you're going to come here and turn on pallet index signals. That's saying, hey, I've done with this pallet. Digital output 13 turns on. It's done. It's full. When the robot sees the pallet present signal go low and go back high, it's going to clear that pallet, and you're going to start back at layer 1, unit 0. That is how it makes it automatic. When it sees that pallet go away and come back, then you're starting back at layer 1. So it's important to get your IO signals set up from the beginning. That's all you need to worry about for the pallet. Is it present in the signal to tell it to index? If it's on a conveyor or a robot operator or a pallet tool, or sorry, a forklift operator needs to come and grab the pallet and you want to signal to somebody, this is how you're going to do it. All right, guys, that's all I got for today. Be sure to check out my next video. The next video, we're going to be going over unit loads, setups, palletizing parameters, picking and placing, what that looks like, how to set it up, and we're going to look at a little bit of customization stuff. So thank you for tuning in, and I'll see you next time.